Last year, the UN officially declared 2025 as the International Year of Quantum, and it has ever been that. This year has been in the making for over 125 years, and the UN's timing looks quite prescient. The scientific, technical, financial advances in quantum these past 12 months have truly been jaw-dropping. Dr. Jonathan Bagger is CEO of the prestigious American Physical Society, or we all know them as APS. And he's also a founding partner of the International Year of Quantum. He's a particle physicist, and he was also director of TRIUMPH, which is Canada's particle accelerator lab in Vancouver. He's committed his career to the responsible advancement of science, and he's here to share a few words with us. Please welcome Dr. Jonathan Bagger.
Thank you. So good morning. It is a pleasure to be with you here at the Quantum World Congress to celebrate quantum science and its many applications. As you just heard, I'm Jonathan Bagger, Chief Executive Officer of the American Physical Society, and I'm here to remind you of the pivotal role of fundamental science in the development of the quantum industry. But before I begin, let me say a few words about APS. So we are a member organization with a mission to advance physics by fostering a vibrant, inclusive, and global community dedicated to science and society. And while the American in our name suggests that we are primarily a US-focused entity, I want to emphasize that APS, in fact, is a truly global organization. We have over 50,000 members in 115 countries around the world. Our members hail from universities, industries, and government laboratories. Nearly 25% of our members are based outside the United States, and over 80% of the publications in our journals feature authors from outside the US. So we aim to be a place where physicists from all cultures and countries can come together to connect, to collaborate, and to advance the frontiers of science. Our meetings reflect our mission in that they bring together physicists from across the globe. Last year, our Global Physics Summit attracted some 15,000 physicists from more than 60 countries to Anaheim, and thousands more to 16 satellite events held in Brazil, Cameroon, Chad, Congo, Ghana, Hong Kong, Jordan, Morocco, Nepal, Pakistan, Philippines, Senegal, Serbia, South Africa, Ukraine, and Uzbekistan. This engagement reflects the importance and the profoundly international nature of fundamental physics and the central role that APS plays in advancing quantum science and technology around the world. Now, this international outlook was not a recent development. It has been part of our field since its earliest days. In fact, it is perhaps fitting that the birth of quantum science can be traced to the North Sea island of Helgoland, where in the summer of 1925, a 23-year-old German physicist, Werner Heisenberg, retreated to relieve his allergies, and at the same time, to puzzle over the paradoxes of atomic physics. And while on that island, he developed the framework for what would later become quantum mechanics, unleashing the revolution that is engulfing us all. Now, the importance of quantum mechanics was quickly recognized within the scientific community, although some, including Einstein, resisted its most radical consequences. And Einstein wasn't alone. The physicist Richard Feynman is claimed to have said, "If you think you understand quantum mechanics, you don't understand quantum mechanics." But all that really doesn't matter, because after 100 years of testing and probing and experimenting, it's clear that quantum mechanics works, whether we like it or not. And because quantum works, we can use it to create applications in industries like the ones we celebrate today. And so for all of these reasons, APS and its partners proposed that the United Nations declare 2025 as the International Year of Quantum Science and Technology. And thanks to the heroic work of diplomats and colleagues from Mexico and Ghana, on June 7th, 2024, the UN General Assembly so declared the year. From its opening ceremony in France to its closing ceremony in Ghana, 1,500 events are being held across 5 continents to celebrate the quantum year and to inform the public about the importance of quantum in everyday life. The aim is to shine a light not only on the history of quantum mechanics, but also on its transformative potential to shape a more connected and inclusive world. And within that framework, I'm delighted to lift up our host, Connected DMV, who sponsored a global industry challenge event with an eye to scaling discovery, accelerating commercialization, amplifying awareness, and increasing talent pipelines across the quantum industry. The challenge vividly demonstrates the extraordinary way that quantum discoveries have moved from theory into practice. Now, the fruits of quantum's first 100 years are with us every day. From cell phones and semiconductors to MRI and GPS, quantum applications are embedded in our lives. We don't even think about them, and most people don't connect them to quantum. But how did we get here? The answer is simple. Through advances in fundamental science, sustained government support of research, and bold investments on the part of the private sector. We could not have achieved that success without all 3: advances in fundamental science, sustained government support, and bold private sector investments. They are the pillars that underpin the entire quantum ecosystem. And together, they are what transformed quantum science into the quantum technologies we now take for granted. So today we stand on the cusp of what some are calling the second quantum revolution, a revolution in which we harness superposition and entanglement, the true quantum weirdness, in service of humanity. After 100 years of effort, we are reaching the point where quantum systems are being engineered to harness the full power of quantum physics. Quantum sensors, quantum computers, quantum networks lie on the horizon. With unmatched power and sensitivity to accelerate drug discovery, secure communications, design materials, model the climate, and even optimize supply chains. So how can we realize that future? Well, first, by remembering the lessons from the last 100 years. I cannot say it clearly enough. Progress depends on the pillars of fundamental science, government support, and private sector investment. All are essential. Remove one, and the system collapses. Second, by remembering that scientific progress depends on international mobility. No nation or people has a monopoly on good ideas. After all, quantum was born on a remote island in the North Sea. And third, by inspiring and preparing the next generation. The breakthroughs of tomorrow will come from today's students, but only if we give them opportunities to develop the skills they need to excel. So today, at least in the US, these lessons are at risk of being forgotten. Proposals to slash the US science budget, if enacted, would cripple fundamental research and slow private sector investment, both here and abroad. And since much of the federal science budget supports students and postdocs, the proposed cuts would also slash the talent pipeline, the workforce of our quantum future. Remember, the quantum revolution was unleashed by a 23-year-old German private docent. Our quantum future demands that we engage the young. In the US, proposed restrictions on scientific mobility would have a similar effect. Today, nations must compete for talent, especially in the world of quantum. Successful nations attract talent and set it free. Mobility restrictions risk driving away the talent we need to build a thriving quantum economy. Talented students and researchers are critical to success, and it would be foolish to drive them away. So the issues I'm raising, though, extend far beyond the US. Just recently, 38 physical societies from around the world, representing countries large and small, developed and developing, authored a document outlining the principles and practices for successful international scientific collaboration. The document outlines 3 principles that are essential for such collaboration. Integrity, tell the truth. Transparency, don't hide stuff. And 3, reciprocity, give as good as you get. Integrity, transparency, and reciprocity. And at the same time, that document calls on governments to enact travel and visa policies that facilitate scientific exchange, remove unnecessary barriers to multinational research, and promote collaboration opportunities for early career scientists. So we know that there are always areas that must be protected for reasons of national security or intellectual property. But much of fundamental science belongs to everyone. Well, as we speak, APS is pressing Congress, the courts, and the administration in support of science funding, international mobility, and the talent pipeline. We are working with our members in the broader scientific community. We see glimmers of hope, but there is still much work to do, and I invite your help, especially those of you from the quantum industry. It's absolutely critical. And at the same time, we're pressing ahead with the International Year of Quantum Science and Technology, not just to honor the past, but to celebrate the future. With advances in fundamental science, sustained government support for research, and bold private sector investment, we can realize a future in which quantum applications transform our world. And by marking the year with the United Nations, we can work to ensure that the excitement of quantum is carried to all corners of the globe so that everyone can participate, no matter who they are, where they live, or where they come from. So let me conclude by reminding us that the world is facing immense challenges, from climate change to clean and sustainable energy to environmental stewardship, food security, and global health. These challenges cannot be solved by one nation, one people, one segment of society, or even one discipline. They will require collaborative efforts to create innovative solutions for each. So let's use this International Year not only to celebrate quantum science, but to commit to a future where its benefits reach all humanity. Together, for the next 100 years, across nations and disciplines, let's ensure that the second quantum revolution unleashes an abundance that will benefit us all. Thank you.